Hey everybody, it's Scott, Simcoe Spring Service, and today I wanted to highlight a new product that we have in our store at www.simcoespring.com. So we've been manufacturing these 2-inch trailer lift blocks in our shop over the last couple of weeks, and I wanted to show you exactly what the part numbers are, what they do, how they work, and what comes in the kit. So there's two different kits that we're offering right now. One fits a 2 3/8 diameter axle, and the other one fits a 3-inch diameter axle. So the 2-inch lift block that fits on the 2 3/8 axles is TLBK-238, and the lift block that fits in the 3-inch axle is TLBK-300. The kit includes 4 brand new 2-inch lift blocks. They fit a 1 3/4 inch wide spring, and it comes with a brand new set of 2-inch longer U-bolts to fit your stock trailer axles. It also comes with all the nuts and washers that you need to assemble it. So these lift blocks are installed fairly easily, and they just go between your axle seat and your leaf spring, and it lifts it up 2 inches at the wheel well. Just like that. And remember, when you're tightening your U-bolts, the torque specs are between 75 and 90 foot-pounds of torque. So manufacturing these was actually quite an interesting process. This is the first time I've actually manufactured a lift block using this design with the recessed plating on the sides. And yeah, I actually wanted to show you exactly how they're made in our shop. All the steel is sourced in Canada. The U-bolts are actually made from a manufacturer in Canada, and the lift blocks are made in our shop in Canada. So it's 100% North American made. And for me, that's pretty darn cool. I like things that are made in North America. So I actually did some compression tests to determine how much these blocks were rated for in carrying capacity. And I was quite impressed by that too. So this is the process that we went through to manufacture these blocks from scratch, from base material all the way up to this finished product. Today we're going to be fabricating up some new trailer blocks. They're 2-inch lift blocks for utility trailers, camper trailers, stuff like that. And they fit the 1 3/4 inch wide springs with the eyes on each end. So these are the blanks that I actually ordered. We're going to be turning these into lift blocks. So today we're going to burn through as much as we can. So I got about 3 buckets worth here. I'm thinking it should give me about 30 to 35 kits worth of blocks for the store. And what we need to do is now clean these all up and get them prepped for welding and painting. So I ordered them pretty close to our final product. I wanted to cut down as much manufacturing process as possible, because the more steps that we have to take, the longer it's going to be for us to get the products out to you guys. So all we have to do is we have to prep and clean all the edges because they came out the bandsaw sharp, so we got to get that cleaned up. We're going to drill holes in them so we can weld center bolts in them. We also have to clean and prep all the plates and get them ground so we can weld them. So I'll take you along for that whole process. I'm hoping that we can get these processed within a week, but it just depends how busy we are. So we'll see. We'll get started on it today, and hopefully we can get it finished in a few days. And at the end of the video, I want to take one of the template blocks that we are going to process today, get it completely done, welded. It won't be painted, but it'll allow us to be able to put it in our press and crush it and just see how much strength it has. I'm looking for about 15 tons without any deformation or anything like that. So I'll show you that at the end of the video. All right, let's get on it. Get her done. So we'll have to find center this way on these blocks now. And I found the best way to do it is I got my little jig here for making blocks. I can put it in here like that, lock it into position, and these little nubs here, it gives you exactly 2 inches. So if I put it on here like that, put my marker in, give it a little drag, make sure it's nice and legible, flip it over, do the same thing. So there we go, now we got a mark on there, and now we can measure it across and punch it for drilling holes. I just got 149 more to go. Yeah, I'm literally not going to show you all of this. It's literally the same thing over and over and over again. So, to the anvil. So now they got the blocks all marked. We're going to punch them all so we can drill them in the right spot. There we go. It's got a lot more to do. Okay, so we'll just load these babies out, put them in here, give them the old clamperoo. Hopefully this little guy will help me and not hurt me. And then we'll drill them all out to 3/8 on this side, and then we'll drill one side out to 5/8. That's pretty much it. So we're going to take about 100 or so center bolts, and we're going to cut them down the length. So we literally just set them in here. We line this head up to the edge of the chop saw deck there. Give them a crank, give them a chop. So every single time we do a process on these blocks, they seem to pick up some burrs. So we got burrs from the bandsaw when they cut each block, and we got burrs inside of here from when we drilled the holes. So now we're going to take our die grinders, we're going to clean them up, and we're also going to give it a little bit of a skim in here and get it prepped for welding. Times 150. So there we go, ground, prepped and ready for welding. We're going to cap each end with a plate of steel after we weld the center bolts in them. Ooh, baby. All our bits and bobs and garbage and little metal shavings and things of that sort. Time for welding. Oh, woo! My hand hurts. Yep. So now that we got all of our little nubs cut, stick them in, get them ready for welding. So that should hold it in place and keep everything aligned and straight and true. So we got a couple of them done now, and then we just got to weld the caps in the ends. So one of the issues that I'm going to have is trying to get these recessed in there about there. I want about a good 1/8 of an inch of recess, maybe about 3 mil, and trying to get that recessed in there and hold it in place. So one of the tricks I found is I bought these little 1 millimeter thick magnets. I'll stick that on there, stick that one like that, and it recesses it in perfectly, and now I can tack weld the corners. What? What, dude?
Oh, that's how you did it.
Yeah. I'm gonna bump this up to 3/16. Give her the old. There you go, magnets come off, and then flip it over and drop that one in. There you go, perfectly recessed every single time, the exact same depth. It's flawless, basically. Now I can do all my internal welding, and when I'm done, I'm hoping that there shouldn't be any overflow over the top, and then I shouldn't have to do any extra kind of grinding or anything like that, and it should be ready for basically sandblasting, painting, whatever I'm going to do to them. I believe the first ones I have raw metal paint that I'm going to use, and then my ones after that I'm going to plan on sandblasting them and painting them. But I got to get some sold first so I can buy a sandblaster. So this is my test block, and what I want to do is I want to practice my welding and see which welds I want to actually do all of the blocks with. So I'm going to do a push weld with ease, But the issue that I have is when I was practicing that, I had too much undercut, and I don't want undercut. So what I might do is just do a straight weld. So I'm going to try ease, and I'm going to do a straight weld, and then I'm going to flip it over, and then I'm going to do a pull straight, and then a pull ease. And I'm going to see which one's the strongest. So I'm going to crush this block, see if any of the welds break, fail, or anything like that. And if not, then we're good to go. And I'm also going to do a crush test on it to determine how strong these blocks are. Now, the rating on the springs is 3,500 pounds. So I'm going to be looking for 35,000 pounds of carrying capacity, because that's 10 times over manufacturer specifications. So we'll do some welding and we'll test it out and see how strong it is. That's not bad. So now I'm going to do push, it's just straight push. I think that one looks a little prettier, but I don't know if it's stronger. We'll test that. Those are E's, and that seemed a lot hotter. My welder's going crazy over there. And then now I'm just going to do a straight pull. Much hotter. I don't know if I got just a good preheat on that, but woo, baby, that's warm. So this is pull. Woo, baby, that's warm. Push. Those are my push welds. And those are my pull welds. I think the push welds look better. Seem to perform a little bit nicer. I don't like the undercut here. I don't like this ribbing undercut here. So yeah, we'll play around with it. See which way works the best. Go from there. Now I gotta let that cool down to room temperature, and then we can go squish her and see how strong it is. It's not even on. Okay, so we got our block in here. And this is all spring steel. So this is spring steel, all these pieces are spring steel, so they're gonna be way stronger than the mild steel blocks that we have. So we're looking for 35,000 pounds, which is 17.5 tons. So it'll be halfway between 33 and 44. So let's just call it 4,000 for a round number. So 4,000 psi. However, my gauge is out by 1,000 psi's. So I'm going to be shooting for 5,000 psi. So we're going to go look right there, and that's where we're looking for pressure to see if it passes my compression test, to see if it will take 10 times more carrying capacity than what the suspension is rated for. Alright, let's give her a squish. I saw a tiny little flake of rust come off of there. But there you go, there's your 5,000 psi. It's bleeding off a tiny little bit. There we go, 5,000 psi. No deflection, no crushing, no deformation. It's still nice and square. So let's see where the failure point is. So let's see where the failure point is so we know exactly what it's rated for. Okay, we're starting to see some deformation now, ever so slightly. Okay, now we're starting to see a little bit more. I would say still it's structurally fairly decently intact. And we are now at 8,000 psi minus 1, so around 7,000 psi. So 7,000 psi is around 30 tons. So now we're at 20 times what they should be rated for. So now we're rated at 10,000 psi, which is around 45 tons-ish, somewhere between 40 and 45 tons. So I'd say that that block would definitely pass any kind of inspection required for this suspension. I'm extremely happy with that. That turned out exactly how I wanted it to. So there you go, a nice little close-up. You can see how some of the forge scale was starting to chip and crack. It's a lot stronger than the steel. It's very brittle though, which is why it's shattering. So now I want this thing to actually fail. So I'm going to stick it in my 45-ton press this way, so it's going to have a lot less strength. Like a lot less strength, like a third probably. And we're going to crush it this way, and we're going to see if we can get some of these welds to pop. I want them to see if they can actually tear or break or fail, to see whether or not pushing or pulling is going to be the, you know, the proper way to weld it. So yeah, let's do that. So the pull side is blue. Give it a little squirt of paint. That way I can keep track of it, because I think when I crush this, I'm not going to see my markings anymore. This is my 100-ton press. I think I said 45-ton before by accident, but now we're going to give her a squish, see if we can get these welds to crack. Now this is my pull side, so I think it's the side that everybody says is going to fail, so I want to film it. The other side, we'll see which one had better penetration, which had more holding power, and then that'll determine which way I weld these blocks together. Okay, it totally collapsed underneath where there used to be a center bolt hole. Well, let's take a look at this thing, see where it see where it failed or if it failed at all. I'm scared to touch it. I feel like it's gonna pop. Okay. So no failure structurally here. I don't see any failures here. No splits, no cracks. I mean, what more do you put a block through? If you have any suggestions on how I can test to see how I can get this thing to fail, I mean, I would say that would be 100% pass all the way around. Let me know down in the comments down below whether or not you think this block would pass your specifications for installing inside a camper trailer. But I think for me, I could weld it in any direction, and that is one strong little block. I'm gonna keep this. This looks really cool. So I think this block surpassed all my expectations when it come down to my crush test. So now I'm gonna make a batch of 40 of them and get them welded together, get them painted, and up in my store. Now I'm probably not gonna do any time lapse of this because it just flashes the whole time while I'm welding. So we'll just get a couple of shots here for you, and then you'll just have to trust me that I welded them all together. So I'm gonna have my welder set to 3/16 thick material, 0.35 wire, mild steel, 351 inches per minute, and 19.5 volts. There you go. Now, so there you go. Now I just got to do that a couple hundred more times. Well, after mucking about with these stupid magnets, they kept falling off, so I tried to weld them, and then they fall off again, and then they demagnetized, mostly. Like and then this one broke, and it didn't work. So, put 6 magnets on, and I put some just like Christmas present tape on there. Some like Scotch tape. And it's been working pretty good. I've done like 6 or 7 of them now, and I haven't had the magnets fall off. I might have to replenish the tape, but it's been working a lot better. I wish I had some like super glue. I don't have any in my shop right now because it's not something we usually use, but I think that would also work pretty good. But yeah, it's working pretty good. Now I can go bang out these last 9 here, and then we'll start doing the full welds on them. So we got all sorts of stations set up in the shop today. We got our painting station here. We got it separated from the rest of the shop so we can ventilate it after we're done painting. And after we get them all painted up, then we roll them over here to our packing station. So in these packages here, we got all the U-bolt kits all bent up and ready to go. I'm in the process of packaging up some of these blocks. So over here I got my welding station. I'm welding everything up, but they get too hot, so I gotta wait for them to cool off. And it takes about an hour for them to cool off, enough that I can flip them and weld the other side, and then about another hour and a half to cool off so I can brush them and paint them. And over here, we're taking pictures to put up on the website for product. So yeah, doing all sorts of crazy stuff. All right, now we can bag all these things up, get them in boxes, and get them in our storefront. Where do I put these? Don't want to block your shot. Here we go. All right, I got 6 kits down. I'm going to put these in the store right now, get them up and get them ready for shipping. And then I'm going to do 34 more kits. So that was a pretty interesting process. Along the way, we actually learned quite a few things, and I'm actually going to be releasing a follow-up video to this sometime in the next couple of weeks on everything that I learned making these blocks from scratch. There was a couple of things that we were definitely not very efficient on. There's a few processes that took way longer than they really should have. And with a couple of different retoolings and a couple of other different products purchased, like especially these little nubs and stuff like that, I'll go through all that in that following video. So keep an eye on for it and make sure you subscribe to catch it. All right, take care everybody, and I'll catch you next time. All right.